For question number 1N from the worksheet area between curves, the problem gives us four equations. It was x plus y equals 1, which I converted to the red line here, y equals x minus 1. X plus y equals 5, which I converted to the blue line, y equals 5 minus x. And the two lines that are parallel, 2x plus 6 and 2x plus 1. So it's important to be able to find the area, this area inside. We need to know the bounds of our integration. And our bounds of integration are going to be determined by these intersection points. So I've given the intersection points. So solving the intersection of the purple line and the red line, I got negative 5 over 3. Between the purple and the blue line, I got negative 1/3. And the green and red had the same y-intercept, so it's at 0. And between the green and the blue line, we get an intersection point of x equals 4/3. So to do this then, we need to then set up our integrals. So our integrals are going to be, the first integral is going to be from negative 5/3 to negative 1/3. And it's going to be this area in here. So I'm just going to frame it out here. And this area, I'm going to highlight in yellow, and this area is going to be the purple line minus the red line. That'll give us the difference between the two lines, which gives us the height, and then we can multiply that by dx. So we end up with something that looks like this, 2x plus 6 minus the red line, which is x minus 1. 1 minus x, and then we multiply that by dx, and that's going to give us the area, that yellow area in there. Okay, and so working that out, we're going to end up with the integral from negative 5 over 3 to negative 1/3, and that looks like it's 3x plus 5 dx. So we end up with 3x squared over 2 plus 5x, and that's from negative 5 over 3 to negative 1/3. Plugging those in, we're going to end up with, looks like it's going to be 3 over 18, or I think that's going to simplify to 1 over 6, 1/6, minus 5/3. Minus, and that's going to end up being 25 over 9, which ends up being 25 over 6. Okay, so 25 over 6, and minus 25 over 3. Okay, so working that out, I'm going to end up with, let's see here, let's use a common denominator of 6. So 1/6 minus 10/6 minus 25 over 6 plus 50 over 6. So this gives me 51 minus 35. Okay, so 51 minus 35 gives me 16, I think it is. 16 over 6, which is 8 over 3 units squared. Okay, so that's going to be the yellow area that I've established here. Okay, and then we do the rest of the problems in the same manner. So we need to then establish the next boundary. The next boundary is going to be at 0. And so this little thin strip here, we need to integrate to get the area. And that integral is going to look like this. It's going to be the integral from negative 1/3 to 0. And it's going to be the blue line minus the red line. So it's going to be 5 minus x minus 1 minus x dx. The distance between those two lines is going to be 4. So from negative 1/3 to 0 of 4 dx, that works out to be 4x from negative 1/3 to 0. And so we end up with 0 minus negative 4/3, or an area of 4/3. Okay, so that would represent the blue area. So this integral is a blue area, and that's our area there. Okay, so which is units squared. And then finally, the last area here is going to be this area from 0 to 4/3. Okay, so we're going to set up that integral. So that integral is going to be from 0 to 4/3, and it's going to be the blue line minus the green line. Okay, so it's going to be 5 minus x minus, and it's going to be 2x plus 1. And then we'll multiply that by dx. Okay, and so that area is going to be represented by this. That green area is going to be represented by that integral. Simplifying this integral, we end up with from 0 to 4/3. It'll be 4 minus 3x. Okay, and let's just make sure I got that right. It's going to be the blue line minus the green line. Yeah. And we're going to multiply that by dx. So working that out, we end up with 4x minus 3x squared over 2 from 0 to 4/3. And that's going to give us, let's working that out, it's going to be 16 over 3 minus 16 over 6. Okay, so that's going to be 16 over 48 over 9, which is 16 over 6. 48 over 18, yeah, which is 16 over 6. And then we're going to minus 0, so we end up here with this area is going to end up being positive 16 over 6 units squared, and this is going to be 8/3 units squared. Okay, so that represents then the green area. So the total area, we just sum those up, and so we end up with 20 over 3 as the total area. When I sum that up, it becomes 20 over 3 units squared as area. And again, what's important is we identify the intersection point to indicate the bounds of integration, and we have to integrate those three areas separately.